assignment. You all, I think it has been posted in your group. I posted it in your group. Go through your assignment. There is 4 questions in that. Work out all the problems and do it in a separate sheet of notebook. You've got that one computerized lab material. No, that sheet also you can use. Many of them are using that sheet. You can use that sheet and then you can give it to me when you're coming offline. Okay, wow. So we will continue with your class. So we have finished your assignment problem and
நம்ம அசைன்மென்ட் 1 எங்க சப்மிட் பண்றது?
which one? You will submit to me. Okay, you're coming offline, isn't it? That time you will come.
Assignment 1
Assignment 1 and assignment 2.
Okay.
If you have not submitted your assignment 1, you submit it on when you're coming offline. Okay, I want it in my hand so that I will submit it to the department. Now next. So we will go on to the next unit. Before going into the next unit, I will just go through all the CT1 portion. Okay. For your CT1, you have your LPP, and in your next unit will be assignment and transportation problem. Your LPP, you should know what is your linear programming problem. Okay. For what it is used. Okay. What are the methods in your LPP? That is your graphical method and your simplex method. Your graphical method, how you should do, you know. And in your simplex method, how you should carry out, you know. And I've seen your surprise test that you've done it really well. Okay, but if at all you have not learned it properly, the students who have not learned it, learn it. Okay, because there will be a definite 5 marks question in your graphical method or your simplex method. Definitely you'll have one question, and then the next unit you'll be having transportation or assignment problem. Okay, in your transportation means what is it? Your supply must be equal to your demand. Okay, and in your assignment, if you see, your rows must be equal to your columns, and then you will proceed. Okay, so that's how you're going to find out your initial basic feasible solution in your transportation problem and in your assignment problem. Okay, so next we will go on to sequencing problem. Next unit is your sequencing problem. Like sequencing problem, from the name itself, what do you understand? Sequencing problem means you have something in sequence. Okay, so here you will be finding out your minimization of whatever sequence you're doing. Okay, and getting your maximum profit. Okay, you'll have your minimum time you will take, but you should get maximum profit. That is what you'll do it in this unit. So in this unit, you will the same thing which you followed in your transportation and your assignment problem, the same thing, but here you will follow up some sequence. Okay, you'll follow up some sequence. For that, what is your time in, time out, whatever it is. Okay, you'll be finding out. So write your heading and put today's date. Today's date is 15. Put today's date, write today's heading, sequencing problems. So that is your next unit. In your sequencing problems, according to your syllabus, you have only 2 jobs and 2 machines, and n jobs and 2 machines, n jobs and 3 machines. Only this will be your syllabus. Okay, you have only till 3 machines, but you've got n jobs. Okay, for so many jobs, how many this 3 machines, how it is being calculated, how it is being processed, that is the way you're going to do this unit. You will be finding out the sequence. You'll find out the sequence, and then you will carry out the problem and get your initial basic physical solution. Okay, so that is how what is it. So first you write what is your sequencing problem definition. Write it down. Sequencing problem.
மேம் போர்டு தெரியல மேம்.
No? You're able to see whoever asked.
Yes, ma'am.
So sequencing problem is the problem of determining the problem of determining Sequencing problem is the problem of determining an order or sequence, an order or sequence. It's the problem of determining an order or sequence for a series of jobs, for a series jobs, for a series of jobs to be done on a to be done on a finite number of service facilities finite number of service facilities so as to so as to minimize so as to minimize the total time taken so as to minimize the total time taken for finishing all the jobs. Okay, so it is an order or sequence for a series of jobs to be done on a finite number of services. Okay, finite number of service facilities so as to minimize. Okay, you're getting the minimum value. Okay, you have to spend minimum value, but you should get maximum profit. Okay, that is the main idea. So minimum time, so as to minimize the total time taken for the finishing of all the jobs. So that is your sequencing problem. Are you finished writing sequencing problem? After writing a sequencing problem, there are three definitions. Okay, in that definition, you have to know what is your total elapsed time, idle time, and no passing rule. Okay, that definition will be there, which is used in the sequencing problem. That is nothing but your total elapsed time is the time taken from the first job up to we finish that job. Okay, your start point to the end point, that will be the total elapsed time. Whereas this idle time is nothing but idle time is nothing but from the name itself. You're not doing any work. In that total elapsed time, the time taken to be idle, okay, the time which is idle, that time will become your idle time, okay, in the sequencing problem. And no passing rule is nothing but if at all you've got two machines problem, the machines how you will consider is you will start it with M1. Okay, you will start it with M1, and if at all you don't have the minimum value in your M1, then you will go on to the machine M2. Okay, if you start the problem, you will start it with machine M1. If at all you don't have minimum value in your machine M1, then you will go on to machine M2. Before itself, you should not go to M2. That is the no passing. Okay, so these are the three definitions which will be used in your sequencing problem. That also we will write it down because in your MCQ they can ask you. Okay, have you finished writing your sequencing problem? Yes.
Yes, ma'am.
So next, write your heading as total elapsed time. Total elapsed time. Total elapsed time. Your total elapsed time is the time your total elapsed time the time total elapsed time is the time between starting the first job, starting the first job and completing starting the first job and completing the last one. Completing the last. So that is your total elapsed time. Next will be idle time. So your total elapsed time is nothing but your start point of your first job. You have the start time, one time 8 o'clock you have to check in, and 4 o'clock you have to check out. Okay, that total elapsed time, the starting time till the job ending time will be your total elapsed time. Okay, and this idle time is the time in this between from 8 to 4. You will have some break time. Okay, that time and all you will calculate. That time will become your idle time. Okay. So idle time on a machine, idle time on a machine. This is considered for machine now, okay? Not for humans. We are doing it for machines, okay? Idle time on a machine is the time, time the machine is the time the machine remains idle. The machine remains idle. Idle time on a machine is the time the machine remains idle during the total elapsed time. In the total elapsed time. So this is your total elapsed time and your idle time. Next is this is one of the rule actually. Okay, you have to follow up this one. That is your no passing rule. Okay, no passing rule in your sequencing problem. This, according to this rule, what is it is, you will start it from machine M1, okay, and then go on to M2. You should not start it with your M2 and then come into M1. Okay, M1 is nothing but your machine M1, machine M2. Okay, so that is your no passing rule. If each of the jobs if each of the jobs is to be processed is to be processed through two machines M1, M2 is to be processed through two machines M1 and M2 it will be of order M1, M2. Then this rule means each then this rule means each job will go to machine M1 will go to machine M1 first and then to the machine M2. When we do the problem, you will understand how you have to do the sequencing. Okay, so you will start it with M1 and then finish it with the M2. If at all you are starting with M2, there is a set of rules. Okay, so now you write it. This is your no passing rule in your sequence problem. Have you finished writing? We will go on to problems. You finished. So we will go on to problems. Write it down. There are 5 jobs. There are 5 jobs, each of which is to be processed through two machines. Two machines M1, M2 in the order. They have given the order also M1, M2. Okay, in the order M1, M2. Processing hours Processing hours are as follows. Processing hours are as follows. The question is they've given you job 1, 2, 3, 4, and 5. 5 jobs they have given, and machines are 2 machines. 3, 8, 5, 7, 4, 4, 10, 6, 5, and 8. Determine the optimum sequence. Optimum sequence for the 5 jobs. Okay. So first I will do out this optimum sequence. Okay. How to find out your optimum sequence. That optimum sequence only you will start the problem. So first you write the question. So this is your question. They have given you 5 jobs and 2 machines. Okay. You finish writing, you tell me so that we will go on to finding out your optimum sequence. Because optimum sequence, with that sequence only, we can carry out the problem. So first we will understand how to find out the sequence, and then we will do how to find out your total elapsed time. So, so first you'll have to find out your optimum job sequence. So now you listen, then you can write it down. So here they have given you 5 jobs. Okay, 5 jobs and there is 2 machines. Whenever you've got this sequencing problem, how many ever jobs has been assigned, that many boxes you will put. Okay, so here there are 5 jobs. So you will put a box like this and you'll put 5 jobs. Okay, 5 boxes. So 1, 2, 3, 4, 5. Okay, we are going to sequence that job. Okay, in the order from the minimum value to the greater value. Now, for that, what you should do is you have to start it from your machine M1. That is your no passing rule. According to that, your no passing rule, you have to keep it started from your machine M1 and then only you go on to machine M2, even if you've got your minimum value. Here, another one for your sequencing problem, what you'll have to do is for your machine M1, if you're taking the value from your machine M1, you will write the order this side. That is from left to right, you will write. Okay, you will write it from left to right. Whereas if you take the values from M2, that is your machine M2, okay, your second machine, you will write it from this side. It will be from right to left. Okay, for your machine M1, you will write it from left to right. For your machine M2, if you are taking, you will write it from right to left. So what is all these things? I will again tell you. Okay, so now what you should do is to write this sequence, if whatever being given in the data, you have to see which is your least value. You have to see which is your least value. So here, if you see your least value is 3. Okay, in the given problem, your least value is 3. It is coming from your machine M1. Okay, your machine M1 and your first job is being allotted. So you will write in your machine M1, you have to start it from left to right. So you will write it here. Okay, we have taken your first least value. Okay, your processing hours been given. From that, you will have to see your least value. Okay, since we have taken from machine M1, we will write it from left to right. Okay, so your job on one is over. You won't take this 4 value. Okay, since we've taken this 3, we won't take this 4. Okay, so this is got over. With the remaining set of values, okay, remaining set of values, you have to see which is your least value. Again, if you see, your least value is 4. Okay, this 4 is coming from the machine M1. Okay, this 4 is again coming from the machine M1. So you will write 4 is coming from the job 5. So you will write 5 here. You won't be writing this value. That is your least value. Okay, that least value is coming from machine M1 and your job is 5. So I've written it 5. Since I've taken it from M1, you have to write left to right. So we have started with 1. Next is fifth job. So this fifth job is also got over. This we cannot take. So we have taken this 4. 4 and 3 is got over. With the remaining values which are there, you will see which is your least value. Okay. So again, if you see, there is least value 5, 5. Two places we have got 5. So here we will start it with your machine M1 because M1 is also got it. So we will take your 5 value. Your job is 3. So we will write here 3. Since we have taken this you cannot take. We have taken this 5. Again, we will see the other values which are not being taken. Your 8, 7, 10, and 5, which is your least value you have to see. Which is your least value? 5. Now this 5 is coming from machine M2. Okay. So since it is coming from machine M2, you will write it from right to left. Okay. And see this is your job value. So fourth job it has been assigned, you will write it this side. Okay. We have taken from machine M2. So you will write it from right to left. Okay. You won't write it from your machine M1. You will take it from your right side. You will take it. Okay. You will write that value. Okay, so here we have finished this one also. We have taken this. So this you cannot take. So this is the last value. This is your minimum value, which is coming from M1 and your second job. So second job. Okay, so this is how you do the sequencing. Okay, I will do it again. I will repeat it again so that you will understand it again. Okay, you can write this and keep your M1 machine if you're taking. You are doing it from left to right. Machine M2 means it will be right to left. I will repeat it again so that you will understand it. It will be clear. Okay, so this is how your this is your question. I will repeat it again. So you're going to find out your optimum sequence. Okay. So when you take it for your machine M1, you will write it from left to right. Okay. You can write it down and keep so that you will understand when you see it again. And for your machine M2, you will write it from right to left. If you're taking values from the given tabular column, if you're writing, you will take it from your right to left for your machine M2. For your machine M1, it will be left to right. Okay, so this is your given data. In this given data, you have to see which is your least value. So here, if you see your least value is 3. Okay, so 3 is got assigned the job 1. Okay, so it is from your machine M1. So you will start it from left to right. I'm writing it as 1. Okay, I've taken that. So since I've taken this 3, I cannot take from this machine M2. So I'm cross overing. Okay, and I've finished with your 1. First job I have finished. Next, with the remaining value, see which is your least value. So which is your least value? 4 is your least value. 4 is coming from machine M1 and your job assigned is 5. So since we have taken it from M1, we will write it here. So we have taken this 4. We cannot take 8. Fifth job is over. With the remaining values, you have to see which is your least value. So this is your least value, 5, 5 we have got. Since we have got one 5 in your machine M1, we will start with M1. Okay, so it has got your job 3. So the job is also got over. So you write it here. This cannot be taken, this you will take. With the remaining values, which is your least value you have to see. So 5 is your least value, it is coming from M2. For machine M2, you will write it from right to left. Okay. So since your job has been assigned as 4, and since it is M2, you are writing from this side, so it will become 2. Okay. So you're finished with your job 4 also. So this cannot be taken. This is over. Next, you've got your 8 and 10. Your 8 and 10, your 8 is your least value. It is coming from your machine M1. And this is your job 2 assigned. So this is how you write your optimum job sequence. Write it down. Any doubts you've got? Sequencing of the problem is very important. With the sequence only, we will then find out your total elapsed time, idle time, and then find out. Write it down. If you've got doubts, you ask me so that you will know how to sequence. You try this problem. They have given you one job. One here also they have given 5 jobs. Okay, they have given your machines to be A and B. 5, 1, 9, 3, 10, 2, 6, 7, 8, and 2. Find out your sequence for this problem. You're finished with the first one. Try out the second problem. Try out finding out your sequence. So here again, there is 5 jobs. So you will allocate 5. 5 works for your optimum sequence. First you'll your 5 one. Okay. So you have to see your least value. Okay, for A, this is A now. A this side, B will be this side. Okay. So how what is your order? Which is your least value? Which is your least value?
1, ma'am.
So 1 means your job assigned corresponding to that is 2. Okay. So since it is taken from A, you will write 2 first. Okay. You're taking your first one. You cannot. So this job is over. Your job 2 year was. Next. Next, which is your least value? 3 year. No. 2 year. So
2, ma'am.
since there is 2, yes. Since there is 2, it is coming from your B. Okay, it is coming from B machine. So your B machine, since it is coming from this side, it is job 1. So you'll write 1 here. You have taken this 2, this will get cancelled. So your job 1 is also over. Now see the values which is being remaining. In that, which is your least value? Your least value is 3. Okay. So since it is 3, it is coming from the machine A. Okay. And your job assigned is 4. From A means it is left to right. So it will be 4. So your 4 is also got over. You're taking 3. 8 can be there. Okay. Then you have got 9, 10, and 7, 4. In that, your least value is 4. Okay. So since it is 4, it is coming from B machine. Okay. So B machine, your job assigned is 5. Okay. So 5 is gone. Your job 5 is got over. And here, if you see, your 7 is your least value. It is coming from your B. So your least. This is how you're assigning, sequencing your job sequence. Okay. This is your optimum job sequence. This is how you do your optimum sequence. Any doubt? Okay, very important. With this optimum sequence only, we will then carry out the problem and find out your total elapsed time and your idle time. So first you have to know how to sequence. Okay, so write it down.